So basically what we're looking at first is determining how fast some crustal plates are moving. So most scientists believe that the Earth's crust is broken into pieces called plates. These crustal plates are moving across the mantle. So here we have our plate. Here's the active volcano, and the plate is moving this way. So that would seem to indicate that this was the first volcano, and then the second, and then the third, and now this is the newest one, the fourth volcano. And as this plate moves over the hot spot, it's moving in progression down. And this is like the Hawaiian Islands. The diagram illustrates how lines of volcanic islands are produced as a superheated molten material rises from the mantle. The mantle material breaks through the weak places in the plate as the plate moves over the stationary hot spot in the mantle. Volcanoes become progressively older the farther away they are from the hot spot. Using the idea that chains of volcanic islands form from crustal plate movement over a hot spot in the mantle, it's possible then to calculate the average speed of the movement. And that's what we're going to be doing. So, as weird as this is, ladies and gentlemen, you need to go find a piece of paper and you're going to put it right up here to this legend where it goes from 0 to 150 kilometers. And you are literally going to trace this ruler onto your piece of paper. And then you are going to measure from dot to dot between the islands. And that will tell you how many kilometers it is. So between Kauai and Oahu, you'll go down here and you'll tell me how, fill in number 13, how many kilometers that is between there. And then you're going to convert kilometers to centimeters, which takes your kilometers and multiply it by 100,000. In other words, you're moving your decimal places um, 5 places over. So just multiply, get a calculator, use your Chromebook, however you want to do that. Then you're going to take the difference between the two areas. So you're going to subtract between islands. So subtract the years between the islands. So up here, we have this one was 4 million years ago, but this is 2.5 million years ago. So you're going to do that subtraction. That's what this column is. And then you're going to take the centimeters divided by your years. Speed is distance divided by time. See, centimeters divided by age equals speed. And you're going to put that answer here. So for example, this is Hawaii to Maui. You're going to measure dot to dot using your handy dandy self-created ruler. You're going to tell me how many kilometers that is. Convert it to centimeters, then subtract 1.2 million years minus 0. Should be really easy. You should be putting 1.2 million years right there. And then you do your division and you're going to get your speed. And we've got some choices down here, so it's just pop in the blanks. Then I've got some questions about that. What's the average speed of the crustal movement? You can do that. So basically, average speed, ladies and gentlemen, is take all 4 of these, add them up, and divide by 4, and you will get the average speed. Then, in which direction is the crustal plate moving? Here's my handy dandy compass rose. North is to the top, south is to the bottom, east is like to New York, and west is like to California. And so use that compass rose to figure out the direction of motion. And if this is the newest island and this is the oldest island, guess what? It's going to go somewhere in that direction. And then you've got some more questions to go through and figure out. Like I said, this is going to take you a little bit of time. Plan on at least a half an hour on this one.